This is question number 9. We are given a diagram with two curves in this question, and we're told that the diagram shows a sketch of the graphs of y equals 5x squared minus 15x minus 8 and y equals x cubed minus 12x plus 1. We're told that the two curves intersect at a point A and touch at a point B indicated on the diagram. Part A of the question asks us to find the x coordinates of the points on the curve where the gradients are equal. So the wording of the question suggests we're looking for more than one point. It says points, and we're looking for the points where the gradients of both curves are equal. Now, as soon as you see the word gradient, that should make you think of differentiation. So we're looking for the points where the gradients of the green curve and the orange curve are equal. What we're going to do is we're going to differentiate the green curve to get an expression for the gradient, and we're going to differentiate the orange curve to get an expression for the gradient, and then we're going to make the two gradients equal to one another. Once we do that, we will solve for x and find the x coordinates of any points where the gradients are equal. So we'll deal with the green one first, differentiating this one. So we have dy by dx and that's equal to, well, we have our 5 multiplied by, and our 2 comes down, subtract 1 from the index, leaves us with 1 here, minus 15x, if we differentiate that, that leaves us with minus 15. And if we differentiate minus 8, it just disappears. So that gives us 5 times 2x is 10x minus 15. So this is an expression for the gradient of our first graph. Now we want to do the same thing for the second graph. So again, differentiating, we have dy by dx and we have our 3 coming down to multiply. Subtracting 1 from the index leaves us with 2. And we have minus 12x is our next term. Differentiating that leaves us with minus 12. And differentiating the number on the end makes it disappear. So what we have now is a second expression for the gradient. This one is for the orange graph. So what we want to do is we want to make these two expressions for the gradient equal to each other so that we can solve for x. So making both expressions equal to each other, this is the one for the orange line and this is the one for the green line. What we want to do now is collect everything onto the left hand side. So we have 3x squared already on this side. We have our minus 12 here. Then we have 10x, which will become minus 10x. And we have minus 15, which will become plus 15. And that leaves nothing on the right hand side, so that's equal to 0. So we'll just move this equal sign over a wee bit. So collecting our like terms, we have minus 12 and we have plus 15. So that gives us plus 3. So that leaves us with 3x squared minus 10x plus 3 equals 0. So remember, we're looking for the x coordinates when the gradients are equal. So it's a case of solving this equation. Now hopefully you'll see that this is a quadratic equation. So we solve that in the usual manner by putting it into two brackets. So we'll do some working over the side as usual. So setting it out as usual. First thing we're trying to get is 3x squared. Now that's achieved by having 3x at the front of one of our brackets and x at the front of the other. What we're trying to get now is 3 at the other end, and we can achieve that by having a 3 in one bracket and 1 in the other. So if we think carefully, then we can get it the right way round first time. So putting the 3 in there and the 1 in here and doing our little cross working. So 3x times 3 gives us 9x, and x times 1 gives us x. Now what we're trying to achieve now is minus 10x in the middle. So we get that if we have minus 9x and minus x, and that means we need a minus sign in here and one in here. Now you should always check that these two multiply to give you your end term. So minus 3 times minus 1 gives us plus 3. So we're okay. So putting those into brackets, we have 3x minus 1 and x minus 3. So first of all, 3x minus 1 equals 0. That means 3x equals 1, which means that x equals a third. Or we have x minus 3 equals 0. So x minus 3 equals 0, which means that x equals 3. So what we have here is our two x values when both gradients are equal. X equals a third or x equals 3. The question was to find the x coordinates of the points, so there's no need to go ahead and figure out the y coordinates. So x is a third and x equals 3 are our two final answers.